Warm good morning to you. I am Smita Thangachan from Department of Physics of Mar Athanasius College, Kodamangalam. Hearty welcome on behalf of Department of Physics to the webinar on Physics and You by Professor C. Vijayan, IIT Madras. We have received around 948 registrations from plus 2 BSc and MSc students as well as faculty members of different institutions from all over India. So we are using two platforms, Google Meet as well as YouTube live streaming to accommodate all participants. Now, let me introduce our resource person, Professor C. Vijayan, Department of Physics of IIT Madras. Our department has long association with Vijayan sir. He has visited our campus as resource person in one of the national level seminar conducted during 2015. Moreover, he is university nominated expert committee member of our board of studies. His research interest includes nonlinear optics, nanophotonics, novel optical materials, photonic crystals, optical properties of nanomaterials, light matter interaction in nanophotonic material, regular and random nanostructures, etc. He has a great passion to interact with students who aspire physics or science as the stream of study. So, with immense pleasure, I welcome Vijayan sir on behalf of Mar Athanasius College and all participants to the session. I also welcome all participants to this platform for active interaction and fruitful deliberations. Thank you. Over to you, sir.
Welcome. Very good morning to all of you. Many people have written on the chat, good morning, but I thought I will answer all of them. Good morning right now. And I hope the morning continues to be good till noon by the time I complete the lecture. By the way, do people have to run away somewhere at 12 o'clock or can I go for some more time after 12 if necessary? Okay. Yeah, if you have, good morning, fine, you already told. Let's stop good morning, the chat box gets filled. Yeah, all of us wish all of us a good morning. Now, we will, you can use the chat box to put your comments or questions or better wait for the interaction session. I plan to have an interaction session and I would like to interact even in between. So this is what I am planning. The topic is physics and you. So nobody knows what I am going to speak about, right? Physics and you is a very topic like that. So can someone tell me what are you expecting in this? Anybody? Anybody please unmute and tell. Unmute both video, audio and tell me and then mute. What are you expecting from this? Some participants, please. Or I will call some. I can see some faces. I will call some.
Ananda Krishnan, can you talk?
Sir, I think നമുക്കത് ഫിസിക്സ് കൊണ്ട് നമുക്ക് ഇനി അങ്ങോട്ട് നമ്മുടെ ഭാവിയിൽ ഏതെല്ലാം രീതിയിൽ നമുക്ക് പോകാൻ പറ്റും, ഒപ്പം തന്നെ ഏതെല്ലാം നമ്മൾ സാധാരണ ചിന്തിക്കുന്നതിനേക്കാൾ ഏതെല്ലാം രീതിയിൽ വിവിധമായ രീതിയിൽ വ്യത്യസ്തമായ രീതിയിൽ ചിന്തിക്കാൻ പറ്റും, അങ്ങനെയൊക്കെ മനസ്സിലാക്കാൻ സാധിക്കും.
അതിൽ രണ്ടാമത്തെ പാർട്ട് ശരിയാണ്, വ്യത്യസ്തമായ രീതിയിൽ ചിന്തിക്കാൻ പറ്റും. പക്ഷെ ഭാവിയിൽ എന്തൊക്കെ ചെയ്യാൻ പറ്റുന്നതിനെ കുറിച്ചല്ല പ്രൈമറിലി പ്രാഥമികമായിട്ട് ഇത്. അതിനെക്കുറിച്ച് നമുക്ക് വേണമെങ്കിൽ സമയം കിട്ടിയാൽ അവസാനം ഡിസ്കസ് ചെയ്യാം. കാരണം നമുക്ക് ഭാവിക്ക് പോകുന്നതിന് മുമ്പേ നമുക്ക് നമ്മളുടെ ഫൗണ്ടേഷൻ അസ്ഥിവാരം വളരെ സ്ട്രോങ് ആയിരിക്കണം. അപ്പൊ അതിനു വേണ്ടിയിട്ട് അസ്ഥിവാരത്തിനാണല്ലോ പ്രാധാന്യം ഒരു ബിൽഡിംഗ് കിട്ടുമ്പോൾ. അതുകൊണ്ട് അടിസ്ഥാനം, ബേസിക്സ് ആൻഡ് ഫണ്ടമെന്റൽസ്, അതിനായിരിക്കും സ്ട്രെസ്. ആൻഡ് ഐ വിൽ നോട്ട് ഗോ ബിയോണ്ട് maybe first year BSc syllabus. Okay. So what you will get is some questions, some answers, some things which are not there in the textbook, and several links and useful links and useful suggestions. That's all will be there. So I could tell you what is expected. Otherwise, expectation do not match. It will lead to, who said, Buddha said, the reason for sorrow is expectation. So that I would like to say that upfront. I have got a lot of nice pictures for you. And please, when I ask a question, you can respond in between. Okay, so I will make my presentation. it is much visual, so the presentation is important. By any chance, if there is some disruption, power disruption or something, we will start again after once it gets. I hope you can see the.
I think the participants should pin Vijay's presentation.
Yeah, but in the YouTube, I am not able to see it. Maybe there's some delay, I think.
Yeah, 5-second delay is there.
Yeah, it is coming up there. Yeah, fine. Okay, so we are ready to start. Yeah, you can note down my website address. There is a lot of material there. You can see that. You can just note down that or search in Google. We start the lecture. The first point I would like to make is you should not start any lecture with a picture of a naked man running around. But it is permitted only in one case. What is that one case? If you are talking about Archimedes, then you are permitted. If you are talking about physics, yes, then it is permitted. Otherwise, don't start your lecture like this. I hope you understood what is the whole story. I don't have to. A picture can tell you a full story very easily. Physics and you. So, what is your attitude to physics? Look at it carefully. I'm going to change the screen quite fast. It says you are like physics. Please note, it is not you like physics. The statement is you are like physics. I don't like you and I don't understand you, physics. But I rely on you. The world relies on physics. Whether you like it or whether you understand it, you need it. And that I hate you. Is this an attitude to physics for most people? I hope not. Or I hope at least we will have some changes if at all it is like that as we proceed. What is physics? There are a lot of possible answers for it. If it were a live class, I would have asked many of you to stand up and tell that. But I had given the answer there. We all know that physics is about the forces of nature. But we also know at higher level that it is also about the nature of forces. We talk about forces, we talk about energy, we talk about how the force manifests itself. So physics is not only about the forces of nature, but also about the nature of forces. You will appreciate it as you proceed in your studies in physics. Let's start with the fundamental question, where are we? Then the first chapter of my talk, where are we? We are very comfortably sitting in our own places, and this is the webinar. Are you afraid of what you see in this picture? Are you afraid of this happening? Is there anyone who is afraid of this happening? We know that it will not happen. So, our statement is we are nowhere. Why we are nowhere? We are in a small college, which is a part of a small state, which is a part of a small country, which is a part of the big globe. Okay, and the big globe is a part of the huge solar system. And the solar system is only in one of the tails of the grand, huge universe of the galaxy, not the universe, galaxy. And that galaxy is only one or more than that, billions and billions of galaxies, part of a meta-galaxy. And all the meta-galaxies form part of something else which you don't know even now. So consider those distances, the size of the universe, and we feel immediately that we are nowhere, we are lost. So my second suggestion to you is, do not start your lecture with a negative statement. That itself is a negative statement. It says, do not start your lecture with a negative statement. So I will also not do that. I can't preach something and practice something else. So I will change it to a positive statement, physics-based positive statement. Look at that. You are now here at time t equal to t1 and space x equal to x1, y equal to y1, z equal to z1. These are very important in physics, two quantities, space and time are very important in physics. So physics starts with drawing a coordinate system and saying, you are now here. And from here, you start your journey in the phase space or whatever. In any space, you can describe it on the phase space and things like that. What is space? Any definition? Somebody would like to tell me what is space? Definition of space. Don't tell it is in between this and that. Space is something between Moon and Mars. That may be correct, but that is not the definition. I want a definition of space without Moon or Mars or matter or anything. Without matter, try to define space. Okay, that is a difficult question. What do you do when you find a difficult question in the exam? Go to an easier question. So I will give you an easier question. What is time? Please don't answer 11 o'clock. That is what is the time. My question is, what is time? Oh, time is the duration for the clock to go from here to here and things like that, or pendulum to go from that way to this way. But I don't want to talk about pendulum. I don't want to talk about spring, or I don't want to talk about atoms emitting wavelength and all. What is time without all that? Without matter. Can you think of time? So matter is very important, right? You heard of the ordinary matter, antimatter. You heard of dark matter. There is one new kind of matter which is discovered. It's called doesn't matter. The student's attitude. When teacher tells some fantastic things, fascinating things, students bother as if that is called doesn't matter. Anyway, let's hope we don't get into that matter. So, can you define space and time without matter? That's an exercise. You can think about it. We cannot solve this issue in a few minutes. But I will give you my definition of time. Actually, it's not my definition. I forgot where I read. Time is a parameter which keeps varying continuously with time. Okay, is that fine? Don't write it in an exam. Okay, let's go back to our picture, interesting picture here. We are at the crossroads of infinities. This infinity of space, infinity of time. Infinite. What is the word in Malayalam for infinite? Ananta. Or Andam illatavan ennu parayille. Adu parayarundo. Ningalude parents okke parayarundo. Andam illatavananu. Andam means end, alle. Andam illengil anantam. Anantam means infinite. Ananta shayanam ennu paranjal infinity il irikkunna aal allengi kedakkunna aal. Appo aarana ananta shayanam? അമ്പലത്തില് അനന്തശയനം നടത്തുന്ന ആളാണോ? അല്ല, നമ്മൾ ഓരോരുത്തരോട് അനന്തശയനം. Because we are situated at the crossroads of infinities of space and time. Space is infinite, anantam. Time is infinite, anantam. So anantashayanam is situated at space and time, the crossroads of space and time. We don't know what is on that side, what is on this side, what will happen here, what happened yesterday, what will happen tomorrow. Okay, we know in our life what happened yesterday before. But what about the beginning of the universe? What happened before the beginning of before the Big Bang? So we don't know. We're really in an infinity of space and time. Look at this picture. Of course, we all know this, but we are often not aware of it. What is the definition of up? Everyone on the world, on the globe, do not agree on the definition of up. Right? What is up? Of course, this is silly. I don't have to spend much time on it, but we are not aware of it. So let's take it forward, this WhatsApp concept. You all want to go to, for higher studies. Many of you want to go to US for the higher studies, America, right? Okay, I will tell you the most easiest way to go to America. The shortest path to America. You should take the globe, Kerala may be here. Suppose Kerala is here. Okay, this is oriented in some arbitrary fashion, but suppose you take it in Kerala, put Kerala on top, then some city of the US will be at the bottom. So what all you have to do is dig a big through hole, and then you just jump in. You will reach United States. See, any other path takes long. This is the easiest way to go. But of course, you know that I'm kidding, and you can't do that because you will say there is lava, there is temperature, pressure, so you can't really do that. Okay, and the earth is spinning, so you can't do that. Yeah, right, all that is correct. But let's do a Gedanken experiment. Gedanken experiment is a Yamantan experiment. And then a Gedanken experiment, it's a thought experiment. We can imagine something, and to get the concepts clear, we can make approximations and go ahead. This is called a Gedanken experiment. Let's do a thought experiment like that. Let us assume that the earth is not spinning, or it doesn't affect us. Let us assume that all the thermal effects, lava, all those things are not there. Suppose it is a uniform sphere, and suppose that you can drill. Okay, so whatever came to your mind first, all that are removed now. Then if you jump it, will you reach? Or what will happen to you? You all know part of the answer. You fall down towards the center of earth. So from the top, you fall down towards the center of earth. Up to that we know. What will happen eventually? Can anyone try and answer? What will happen and why will it happen?
Oscillate.
Please unmute and talk. Gino, who is speaking? Gino or who is
Yes, Gino is. നമ്മൾ ആ ഒരു സെൻട്രലിന്റെ ആ വിത്ത് റെസ്പെക്ട് ആയിട്ട് ഓസിലേറ്റ് ചെയ്യുമായിരുന്നു.
അതിനെന്താ കാരണം? എവിടുന്ന് ഈ ഓസിലേഷൻ വരുന്നത്? ഉത്തരം ശരിയാണ്, പക്ഷെ എന്താ കാരണം?
കാരണം സിമ്പിൾ
ഇതുവരെ നമ്മൾ വീണിട്ട് എർത്തിന്റെ സെന്ററിൽ എത്തുന്നവരെ എല്ലാവർക്കും അറിയാം. പിന്നെ എന്താ സംഭവിക്കുന്നത്?
അറിയില്ല സർ.
പിന്നെ എന്താ സംഭവിക്കുന്നത്? ജസ്റ്റ് ആലോചിച്ച് നോക്കും. നമ്മൾ അവിടെ എത്തി, ഇനി എന്താ? അപ്പൊ നമ്മുടെ സ്പീഡ് എത്രയായിരിക്കും? Free fall is equal to something is dropping, and what will be the speed after some time, distance and all that. You know that, all that story, right?
Yes, sir.
So when you reach here, okay, what I will do is the question I will partly answer and drop. The answer is that you will oscillate, you will never reach. But I would like somebody to just note down and think of some explanation, and at the end we will take it up. Question hour we will take it up. So I'll just note down what we have left. Okay. Yeah, we'll proceed. Okay, I'll leave it at that and proceed. You all know that there is theoretical physics, experimental physics. Actually, they're all part of the same game. Without theory, the experiments don't work. And even if you do the experiment, you have to understand what it is. You have to analyze the data. So simulation, theory, simulation, experiment, all that go hand in hand. Today, all are very powerful. You should do experiment. You should plan theoretically first, and then do an experiment which is theoretically okay, and then do simulation and try to see what will happen first. So it's all part of the same thing. It's all part of the same thing. How do you think the wheel was discovered? Without any theory and simulation. Wheel was not discovered like this. Wheel was, why? Because there is no computer. Somebody will say there is no computer those days. Nowadays, colleges are given, all students are given computers, at least in Tamil Nadu, I don't know about Kerala and all that. But we are all given one computer. Instead of desktop and laptop, it is called the neck-top computer. So those people had the neck-top computer. They worked all this on the neck-top computer, all the theory and simulation and procedure. So there is not really big difference between experimental physics, theoretical physics, and all that come together. You need concepts clear, your basic physics clear, before you analyze the data of an experiment. It is not that something falls on your head and immediately you discover all the physics, the laws of physics. It's not like that. If an Apple computer falls on your head, yeah, you will get an injury, but other than that, you will not be able to. By the way, this picture also reminds me of something else. Suppose really a computer fell on Newton's head from some other planet, where the science is advanced. It is possible. They would have made some computer, and they would have come in a spacecraft and shown a computer to Newton. What will Newton say? I don't know what is this. It's all mythology. This is all non-physics. It's all humbug. This is not according to the principle of physics. It cannot happen. Why? Because it doesn't know any electricity magnetism. All electricity, magnetism, electronics, computing, everything came after Newton's life. So Newton does not know about a device like this. Okay, that is just incidental. So Apple is good for your physics as well as your physics. We can't have a lecture without talking about Newton and Apple falling on Newton's head. Newton's first law. Let's talk about Newton's first law. We all know Newton's first law from childhood onwards. We have been, those who are writing JEE exams would have started from kindergarten. What is Newton's law and all that. So Newton's law has two important concepts: the concept of inertia and the concept of force. So let us look at the first. For the next few minutes, we'll look at some of the Newton's laws and something which is not given in the books. What the question to be asked is, what makes a system change its state of motion? If a system doesn't change the state of motion, no questions asked. If you comfortably sleep in the bed, nobody will come and wake you up. I'm at equilibrium. If your mother comes and wakes you up, no, I'm at equilibrium, no questions asked. Only when you want to break the equilibrium or you want to change the state of motion, you need force. Okay, so this is called, this is the state of motion. And this is a change in state of motion. How did the change occur? So that is definition of inertia. And this is the definition of force. Force is that which changes or tries to change the state of motion. So the state of motion is now changed. Okay? So what makes a system change its state of motion depends on many factors. Depends on force primarily. So how do we state Newton's first law? Don't write it down in any exam or anything. You will continue your state of motion until there is sufficient commotion. That's what Newton has taught us. Let's proceed. I will give you some exercise based on Newton's first law and second law. We all know that a heavy object can be lifted on the surface of moon. Okay? I said I have written here cow, but I'm really not talking about a cow. It's little calf which you can somehow lift. Okay, little calf you can. Cow you cannot think of lifting. So you are trying to lift that. Is it easier on the moon compared to Earth? That's the question. Is this question is not really related to Newton's law, but yeah, I see a lot of yes and no and all that. Yes, it is easier. I think most people agree. Majority says it is yes, you can lift. Fine, let's accept that. Now comes the question: what will happen when you are lifting a cow? The bull gets annoyed and bull comes charging at you. The bull comes charging at you. So now the question is it easier on the moon to stop a charging bull? Just as it is easier to lift a cow on moon, is it also easier to stop a charging bull? Okay, again, don't say that there is no air on the moon, there is no bull on the moon and all that. No, not that. Let's assume all those ideal conditions. I mean, I don't know whether it's ideal or not, but let's assume all those complications are not there. Yeah, most people say no. Why? Then you know the difference. So many people have written, Renchita has written no. Can Renchita please tell us why no? Technical reason for that. Agnes says because we are also experiencing. The crucial point here is, in one case you are talking about weight, and the first case. The second case you are talking about the mass. Mass and weight are different. How does that come in? Here it is a weight. So acceleration. To what acceleration the planet pulls it. That's what matters. But what matters here is momentum. Change of momentum per time. That is force. Force is the rate of change of momentum. So you have to change the momentum to stop something. You have to bring the momentum to zero. I said charging bull. So the initial velocity is very large, the final velocity should be zero. So what matters here is mass, not weight. So this is a subtle difference which I have to Think about it. Now, we know that moon is always in a state of free fall. Does anybody have a doubt? The stone will fall down because the earth attracts. Earth attracts everything. And what is the range of gravitational force? Infinity. So earth attracts everything. Okay, let's not worry about other objects. The earth attracts the stone and the earth also attracts the moon. So Chandrayaan has become very easy. Just wait for the moon to come and fall on earth and then get onto that. That way, can we do that? Will it really reach us? So the question is, when will it finally reach us? Or why doesn't it? Of course, you know that it won't reach. So why doesn't it fall? Why doesn't the moon fall? Okay, question number 2, which you can think of. If we are not able to answer in this meeting, you can always look up the Google or something like that. Okay, somebody just said centripetal acceleration or something. But when I ask a question, please don't say word, something, anything about, you ask anything about flight, people will say Bernoulli. Bernoulli, is it Bernoulli? That will be the answer. Is it Bernoulli is not an answer. We should say what is happening. So centripetal force, calling names that you can call your friends when you don't like them, you can call them names. But in physics, we have to give a logical explanation. So somebody can get ready with a logical explanation, we'll take it up later. And another question, sub-question. If the moon is in a free state of fall, which it is, why there is weight at all on the moon? If something is on free fall, the weight will not be there, experienced. But we experience some weight anyway. It's not weight free. So what? That's the next question to be answered. Somebody can remember all the questions at the end and will generate the answers. Now I want to bring you, okay, we have covered first and second law. Now we'll talk about the third law. Newton's third law brings you a very important and interesting thing. I have written there, BSc students can understand. Those who know calculus can understand. Please go through the steps. It is very easy. It's just 2 steps. I have written the Newton's third law, and in 2 steps, I have got an equation which says conservation of linear momentum, right? So you can actually verify this by yourself, and you can convince yourself that Newton's third law is actually a statement of the conservation of linear momentum. Okay, conservation laws are primary, more important than Newton's laws or any other laws. Conservation laws are a very, very interesting and very primary space in physics, primary position in physics. I will tell you a short story. Isaac Newton was giving a lecture in a college on his laws. And of course, he came on a horse cart. The other vehicles were not invented at that time. So he tied the horse onto the tree, nearby tree, and he was giving a lecture. And it was not an AC room because AC was not discovered at that time. So the windows were open and the horse was also listening to the lecture. And Newton was talking about Newton's third law. At the end of the lecture, everybody appreciated and he went back. He went back, got into the carriage and asked the horse, okay, pull. Suddenly the horse turned back and said, how can I pull the cart? Okay, I can pull, but what the use? The cart will not move. Newton was shocked. Why do you say so? No, I didn't say, you only told. Every force, every action has an equal and opposite reaction. So the force exerted by me on the cart is equal and opposite to the force exerted by the cart on the horse. So they cancel each other and we cannot move. You only told, you just explained. I was listening to your lecture, right? I will repeat it just like F12 is equal to minus F2, and I have written there. The force exerted by the horse on the car is exactly equal and opposite to the force exerted by the cart on the horse. So why do we move? സാധാരണ ചോദ്യങ്ങൾ ചോദിച്ചാൽ എല്ലാവരും ഉടനെ പറയും ഒരു ഹിന്റ് തരാമോ, ക്ലൂ തരാമോ? ഓക്കെ, ക്ലൂ തരാം. ഞാനൊരു ക്ലൂ തരാൻ പോവാണ്. പിന്നോട്ടു മാത്രം മടങ്ങുന്ന കാലുകൊണ്ട് അയ്യോ മുന്നോട്ട് പോകുന്ന ആളുകൾ. കുഞ്ഞിനി മാഷ്ടർ കവിതയാണ് ക്ലൂ. We'll see the answer later. Let me note it down. See, sometimes it may overstep, so people who have other work can go, and those who can find the time can sit back and look at the questions. Otherwise, those they can always see the YouTube later. Okay. So Newton's third law is some people have given the correct answers. We'll see it later. We'll discuss it later. Newton's third law is a statement of conservation of linear momentum. So just like we rephrase the first law, let us look at Newton's third law in this fashion and rewrite Newton's third law. Suppose an object, how do we do problems in Newton's third law? An object moves, mass m2 moves with a velocity v2, and another object moves with a mass m1 and velocity v1, and they collide. That's Newton's third law. So how do you write this? What will happen in this? The Newton's law says the linear momentum before lunch is equal to linear momentum after lunch. That's a statement of Newton's law. So the point here is Newton's law is actually a restatement of the conservation of linear momentum. Okay, laws came first. These concepts were developed much later. The symmetry and those things at higher level. People don't even hear of it in the MSc level. G. Shankarakkurup എഴുതിയിട്ടുണ്ട് നാളമാണ് ഞാൻ പഴന്തുണി നൂൽ തിരിയല്ല നാളമാണ് ഞാൻ പഴന്തുണി നൂൽ തിരിയല്ല തിരിയും നാളും തമ്മിൽ വളരെ വ്യത്യാസമുണ്ട്. So our question now is, why does the flame have that shape and that color? Why is the color not the same everywhere? There is a blue color which is not shown here, yellow color, red color, all sort of colors. Not all sort of colors, some of these colors, and black also. So why does it have a shape? Again, if you want to have a clue, this is the clue. Suppose you go to the outer space. Here I have to make a clarification. Outer space, people say that outer space there is no force or anything like that. Nothing like that. All gravitational forces of our galaxies, of the planets, everything goes to infinity. So when you say outer space, it really, outer space can be anything after the solar system and the galaxy and all that. In between also. That is called outer space. So it's not that there is no force anywhere in the outer space. But in physics, when we normally say outer space, we talk about a location where all the forces cancel out and there is no net force. The attraction due to all different things cancel out and there is no net force. Suppose you go there, the clue is this. The clue comes in the form of a question. Why does, the question is why the shape and why the color? Okay, the shape part, I'm talking now about the shape part. What will be the shape? And of course, also what will be the color? If you go to that place, zero gravity, all the forces cancel out and there is no net gravity. Suppose you go there, what will be the shape? Yeah, I have seen some people have given the answers. We will discuss it. Yeah, convection, somebody said. So, convective flow is absent in microgravity. It's called microgravity, not exactly zero gravity. That's what people say. So that is how your candle will look like. In മറ്റുള്ളവർക്കായി സ്വയം കത്തിയേരിയുന്ന കാണ്ടിൽ ഇങ്ങനെയായിരിക്കും കാണുന്നത് അവിടെ പോയി കഴിഞ്ഞാൽ. Okay, we move on to the next topic. Have a good look at the picture. First picture is before the apple fell, and the second picture is after the apple fell, immediately after the apple fell. But if you look closely, I have modified the picture, original picture, and you will see some objects there. What are they? They are not waves. Somebody wrote waves. What are they? Have you seen it anywhere in your lab? Those objects? Newton's rings. Okay, now this is the point which I want to talk about. Newton's theory was that light is a series of particles, which, yeah, many correct answers are coming. And then Huygens, who lived around the same time, Huygens believed light goes as waves. So is it waves or is it particles? Physics can answer things only by an experiment. So somebody brought in, Newton didn't believe in waves at all. No, light cannot go as waves. That's what Newton said. But somebody brought an experiment. Somebody showed an experiment which cannot be explained with particles, which can be explained only with waves. And what are the phenomena like that? Which cannot be described with particles, but which can be described only by wave nature? That is interference and diffraction. So the patterns like what you see, that is the experimental proof that Newton was wrong. And who invented these rings? What are they called? So Newton himself, the discovery or the invention of Newton himself disproved himself, his theory. If Newton is the one who invented, or rather discovered, it was always there in nature and all that, Newton discovered it, this Newton's rings. And that can be explained only if you have the wave theory. That was very interesting. So if Newton was very intelligent, he would have supported the wave theory. He would have believed that, okay, wave theory is also fine. But if Newton was extremely intelligent, the physics would be different. He would have done this. Of course, Newton is intelligent. He is a genius, no doubt about it. Okay. If he didn't know electromagnetic theory, it is just because all that came after he lived. But the point here was about the wave nature which came, which was proposed by Huygens at around the same time, which Newton opposed. So finally, the light particle or a wave. If you look at that picture and meditate for a few minutes, you will know whether the light is a particle or a wave. Okay, now you all understood that particle or wave. And let's move to the very interesting story of the electron. The confusing story of the electron. The story of the electron is that J.J. Thomson got his Nobel Prize for inventing the particle electron, the charged particle electron. For that. It is a fantastic discovery. That's why it was given the Nobel Prize. But after 30 years, around 30 years, somebody else gets a Nobel Prize. And who is that? That is Thomson's son. J.J. Thomson's son, George Paget Thomson. He did an experiment along with Davison. And of course, Davison and Germer experiment is another experiment, parallelly, which proved his experiment, this young man's experiments proved, along with other experiments, that electron also behaves like waves. So it is really confusing. Particles behave like waves. And what we thought as particles like electron behave like waves. And what we thought of as light, as wave, which is light, which behaves as particles. So both of them behave like. So we are really confused. What is the reality? Is there something called reality? People have done experiments of interference with electrons and light and all that. So it's like a teacher was explaining this. When you do an experiment like the Compton scattering, light and electrons behave like particles. Compton scattering you all done. You use a collision of two particles, collision of photon and electron and all. But when you do interference, it behaves like a wave. Then the smart student in the class had a doubt. Sir, when I'm not doing the experiment, when I'm doing Compton effect, it behaves like particle. When I do interference, it behaves like a wave. So when I'm not doing the experiment, but teachers are also smart. Don't think that only students are smart. So the teacher said, in physics, experiment is ideal. When you're not doing the experiment, you can't talk about what it is. Good answer, right? So light and electron, they look into your practical record. When you are about to do the experiment, they look at the schedule. Okay, you are doing a Compton effect, we will behave like particles. Next day, you are doing a diffraction, then we will behave like waves. This is an interesting book called Tompkins in Wonderland. Tompkins in Wonderland by George Gamow, the great George Gamow. Very nice. That book is, I think it should be available in your library. Please read it. Fantastic book. This story is from that. Even if you don't read it, it's okay. I will read a relevant part of it. It's about about to retire, a bank clerk of some 50 plus, about to retire, bored in life. He is the hero. What a nice hero. Just imagine the hero entry in the movie. Our hero enters. He's a bald old bank clerk who is about to retire. No connection with physics. But then there is a professor who comes and gives a lecture in that village, public lecture. And our hero goes and attends the lecture. He was interested in physics in childhood, so he goes and attends the lecture. I think you can understand what will happen if a physics professor gives a lecture on relativity, quantum mechanics, and all that, and a retiring bank employee who didn't do any physics college in the college, he attends that lecture. What will happen? Some comment, please. What will happen if a professor gives a lecture on quantum mechanics and an old bank employee attends that? Questions and questions? No, it's simpler. Answer is simpler. He's an old, tired person. He sleeps. Simple answer. He sleeps. So our hero enters sleeping. There was a Kathakali thing, and the artists were all drunk. So they went abroad, and that particular brand of liquor he was not used to. So Hanuman was he couldn't wake up after the drink, and the time has come and he has to appear. Then they didn't know what to do. Time and he's still sleeping. So they brought Hanuman. Some 4 people carried him and said, "This is the Hindu god who is so powerful that once he wakes up, the whole world will be destroyed." Something like that. They managed to escape from that. Okay, so what are we talking about? We are not talking about religion. We are talking about what were we talking about actually? Yeah, what will he do? He sleeps. Our hero sleeps. Our hero enters sleeping. And then he dreams. That's the good thing about sleep. Somebody said you have to live up to your dreams. So what is the first step for living up, having a dream? Sleep. So you should occasionally sleep in the class, and then you will have dream. And he dreams fantastically. Read that book. He reads he has gone to a world where the speed of light is very small. The value of Planck's constant is very high. And he sees all weird things, funny things happening there. And the professor also comes in the dream to explain that. Okay, this is happening. An elephant, and okay, I want to steal the charm of that, buy that book and read it, or go to the college and read it. Tompkins in Wonderland, that book by George Fremont. That's the story about it. Why? He gives an explanation to our relevant. What is the context? What is the relevance here? When nobody is looking, this is the question. When I am looking, it is either a particle. When I am doing an experiment, light and electron behave like either a particle or a wave. But when nobody is looking, what will happen? That is the question the student asked. The professor says, when nobody is looking, nobody can know how they behave, and your question is meaningless. That's what he says. Okay, so you can read more in that book. As I said in the beginning, I will provide you different links and pointers which you have to go and pick up, and the ultimate answer came from quantum mechanics. So we move on to the next part, understanding matter and radiation. You know this person. He says quantum mechanics is a description of the behavior of matter and light in all its details, and in particular, the happenings at an atomic scale. Things on a very small scale behave in a totally strange way, and we can't really have models. So is light a particle or a wave? That is his answer. They do not behave like waves, they do not behave like particles, they do not behave like clouds. See, what do you mean by explaining? Explaining means telling something which we don't understand in terms of what we understand. What we understand are these things, particles, waves, and all that. If that is not going to behave like for that, so our pictures are not complete. The particle picture or wave picture is not complete. The ultimate answer is the Schrodinger equation, quantum mechanics. So read more in what Feynman says about this. The famous experiment and all that are there. Feynman's experiment on dual nature and all that. So we go to the next part of our how to enjoy physics. Richard Feynman is the greatest physics teacher perhaps, and he says, I wonder why something happens. I wonder why I wonder. I wonder why I wonder why. That's the level of understanding. If you want to enjoy physics, you have to do that. Now let's go to an example from Feynman's class. We're trying to enjoy physics. So let's have an example. The example is that he asks, okay, I think it is not completely written here. Yeah. The question was this. Feynman asked the class, a toy dog. Nowadays, battery toys are more frequent, but several years back, battery toys were not there. You have to wind the spring. You have to wind the spring and some dog will move. That was the toy. So why does the toy dog move? The question is, why does a toy dog move? And Feynman said, the toy dog moves because the sun is shining. Then the smart student immediately objects, no sir, what has the sun to do with my toy dog? It moved because I wound the spring. Potential energy, kinetic energy. I wound the spring. That's why. Okay, then Feynman coolly asks, why are you able to wind? Where did you get that energy to wind the spring? I eat. What do you eat? I eat plants. Now you may be wondering, I eat animals. So it's not applicable to me. No. If you eat animals, what do the poor animals eat? Plants. So it comes back to plants. So, and where do plants get energy? Because the sun is shining. So what you can do after the lecture is go to your younger brother or friend and ask them this question. Prove that the Bullock cart is a nuclear powered vehicle. The statement is, the Bullock cart is actually a nuclear powered vehicle. The clue is this story. The clue is this story, and you have to find the answer and you have to fool your friends, brothers, little brothers, all those people. Okay? Feynman gives lectures in a very nice way. All of you should read the famous Feynman lectures. I'm quoting one incident from that. That is the famous the question where there was a student who failed in physics. So because he failed in physics, he could not get a better job. He was a traffic inspector. And the traffic inspector is standing at the junction. And our professor is driving at 70 kilometers per hour. The speed limit is 60 kilometers. So the student, oh, now he's coming. He failed me in physics. Now he's driving. So he goes and stops the professor. Sir, I am arresting you. Why are you arresting me? Because 70 kilometers per hour. You are going at 70. Who said I am going for 70 kilometers? You know that the college is only 2 kilometers from here. And who is going to travel for 1 hour? It's that just 2 minutes I will reach there. The policeman start thinking, okay, what I meant is, if you go like this, you will cover 70 kilometers. Who said, just look at that. There is a curve in the road. If I go like this, I will hit against a tree. If I go like this, I will hit against the tree. So what is the problem? Then he thinks, no. Actually, what happens is, if you go like this, he thinks he doesn't know what to say. So he says, if you go like this, after 1 hour, you will cover 70 kilometers. Very good. But can you arrest me before I do the crime? You bring gold for 30 kilos and hundreds and kilos of gold, and finally sometimes you will be caught. That's all. But if you have to be caught, otherwise you can live happily ever after. But if you have to be caught, you have to prove that you have done something wrong. So how can you arrest me now for some crime I am going to do after 1 hour? Then he says, no. What happens is, at this instant, you are going at 60 kilometers, 70 kilometers per hour. Then the professor says, at this instant, I am not going anywhere. At time t equal to t1, x equal to x1. At time t equal to t2, x equal to x2. So at this instant, I am not going anywhere. Okay, you all know this. What is the definition of velocity? What is the answer to this puzzle? Bring in calculus. The concept of limit. Consider a small distance delta x in a small time delta t. You squeeze delta t tends to 0. You squeeze delta t to 0. And as delta t tends to 0, you have dx by dt. That's velocity. That is how but then of course the person who failed in physics could not explain all that. So the professor was not arrested. Now I start giving you some take homes. I am going to give you a lot of take homes. Please take all that, whatever I am giving. The first take home is this. There are 2 books written by, not exactly written by, but about Feynman. One Surely you are joking, Mr. Feynman. And the subtitle is Adventures of a Curious Character. That book, it was available on roadsides for some 30 rupees and all that some years back. It must be. If it is not, you ask your teacher or parent to buy it for you. First book, especially. Surely you are joking, Mr. Feynman. I'm only talking about the first book because I'm sure if you read the first book, you will automatically read the second book. Buy and read the second book also. Second book is for a little advanced, PG, UG final year people. But anybody can read. Even the common people can read the first book. So that's my first take home for you. Two interesting and inspiring books. They are very different from any book we have read. Do you know that Feynman used to repair radios when he was a child, when he was in schoolboy? Feynman used to repair radios. Okay, that's fine. Everybody might have tried that. But what is his method of repairing radios? He doesn't need a screwdriver and all that. He won't open the radio and look for various components. He will listen to the sound of the radio and tell you what is wrong. That is how he will repair that. Many such interesting stories are there. It's all interesting stories related to physics, related to thinking, and you will all enjoy it. The first. Second book is about his adventures. Even he became the famous scientist, his adventures with physics continue. For example, he used to break locks and all that in the most secret thing in the USA, that is the atom bomb project and all that. So he used to play with intelligence. He used to play. So all the stories are there, and the Challenger disaster and all that is written in the second book. That's my first take home. You will have a few more take homes. If you have noted it down, you just have to look for these books, and if it is affordable, you buy it. Otherwise, ask the college to buy 10 copies or 20 copies, or ask your parents to buy it for you. The second take home I would like to give you is the name Walter Levin. Many of you may be already familiar. Attend Walter Levin's lectures. He is teaching a simple pendulum in this picture. How do you teach simple pendulum? By yourself becoming a compound pendulum. That is what he does. And he teaches this way. So my second take home for you is, for those who are not new to him, is to look for Walter Levin in YouTube and look at his lectures, the way he demonstrates every concept. Yeah, some people are already familiar with him. If you are not familiar, please have a look. He is a very popular figure. I think all of you might have seen his books, but there is much more beyond. He was a professor in IIT Kanpur, retired. And after retiring, he's going to villages and teaching people and doing experiments for them and all that. So he's a really genius, and he contributes to society, continues to contribute to the society. So he has a channel. Please note down that address of the channel. Very interesting demos, lectures, courses, all fantastic explanations. See how he has written on the board. Very clear, and along with the demos. So he has a lot of talks and demos. There is something called Anveshika. You can look at what it is by IAPT. He is the vice president of IAPT. So primarily, first you can look at that website. This is the next take home number 3, which I would like to give. Take home number 4. He's again an IIT product, Arvind Gupta. He did his post-graduation in IIT and got a very fantastic job, but he left all that. And now his aim is to popularize thinking and science, wonder from waste kind of thing, all over the villages. Cheap. He does demos. He asks you how to make things, but zero cost, practically zero cost, a few rupees. You don't have to ask your parents or anybody. You can do it. So the Joy of Indian Toys is a book by him. Not only the demos. You don't have to buy these books. If you go to his website, just search for Arvind Gupta. Instead of remembering a complicated web title, just search for the name. You will see a lot of books there. Lot of books, interesting books. In fact, too many books are there. And too many demos, not only on physics, but also other related. Some of these pictures are from some of those demos. So this is my next take home. Now let's talk about C.V. Raman, the man who thought differently. That is how he was able to make the discovery. People have seen light coming out of objects, but he thought differently. He also saw light coming from a liquid, but he thought differently. It's not because of impurity fluorescence. It is because of a new process happening at molecular level. That is what he has discovered. He went to the United States to give everywhere. He went everywhere to give lectures on the Raman effect. So he demonstrated Raman effect in one university. And after that, they were all very happy, and there was a party, and drinks were supplied. In abroad, in universities and all that abroad, they use drinks also. I don't know. Many people drink all over the world, but only when Indians drink, they start beating their wives and all sort of issues, losing their money and all that. So anyway, so they asked Raman to drink, but Raman said he will not drink. Why don't you drink? Raman doesn't drink. So he said, I came here to demonstrate the Raman effect on alcohol and not the alcohol effect on Raman. That is what he said. Okay, Raman's contribution is explanation of why the sky is blue. If you search the internet, you will see a book like this. I mean, it's not a lecture. The lecture was not recorded. It is a lecture. Of course, there's written books and papers in Nature and all that. But what I'm talking about here is a simple lecture given to school students by C.V. Raman. Its text is available free. I think some people are marketing it also, but it's available free in the internet. If you don't see it, you can email me. I will send you. And it is very nice. Everyone should read it. This is the quote from that. He starts like this. Why is the sky blue? Because the sky is there and I am there. That's what he starts. Then he says, the best way of answering a question is to raise more questions. That is how it goes. Fantastic. He says, yeah, that's what he has written. You see a little, the message of that talk. You see a little, and even this little is enough to trigger you to a world, a wonder world of physics. That's the inspiration he gives. But then, is the sky blue? Who said the sky is blue? This is a picture of the sky. So he asks the question, why? Why the sky is not blue? Why is the sky not blue in the night? He asks several questions. The best way to answer a question is to ask several questions. What are clouds? Why do they have that shape? Why are they hanging at that particular height? Why don't the clouds fall down? Why is ice colorless and snow white? If the sky is blue due to scattering, that's what everybody will say. If the moment I ask this question, they will say, everyone will say scattering. If the sky is blue due to scattering, let's say dust. If all the dust is swept off, all the clouds are swept off the sky, then it is even more blue, not less blue. So this is, and why is the sky not blue? All these questions are discussed and answered in that freely available book, talk by C.V. Raman. So that's my next take home. Sorry, that is wrong. Not demos, and demos are not there. That I think that should have been somewhere else. It's just a book, just a booklet. I mean, just read a PDF file is available. So just read his message. I'm not going to discuss the message because that is there in the book, and once you go and read the book, you will really see it in its full glamour. Now I'm going to tell you how you can become a genius. How do you become a genius? Go and sit under the nearest apple tree. Will it work? No, it won't work. And Kerala, don't try it. Because Kerala, not only we don't have apple trees, we have coconut trees. And if it falls on your head, situation is not going to be very pleasant. You are not going to discover creative and imaginative things. So, what is the method? There must be some other method. That is what Louis Pasteur has said. Chance. Okay, we'll all have such chances in our life. But chance prefers only a prepared mind. A prepared mind. You must be thinking about the problem. He was thinking about or you can start thinking once you have some chance. But what the books don't tell you, books tell you as if the apple fell and he discovered gravitation. No, after that, many years later only the theory came out. Lot of struggle, lot of thinking, lot of making models, equations, differential equation, and that's so finally it came out. In fact, he could not even write it in a proper language because there was no calculus at that time. So he invented calculus. And did all that. That is the long story. Similarly, this picture at the middle, you can see the other picture, which is the Kekula's story. Kekula, Fleming, there are a lot of such stories. Well, example, not stories, real life examples. Kekula was thinking of the benzene ring. He was sure that it is not a linear chain, like you all know the chemistry of benzene and all that. C2H2, then not that kind of chain, the what is called the homologous series. So once it is 6, there can be a different compound. And that compound will not be linear. That much was clear because the properties are related to the structure. Okay, but then he was sleeping and suddenly he had a dream of. Okay, we all think of, sometimes we do have dreams of snakes and we get frightened. But because he was thinking about it, because he has done the homework, he could connect it and say that it is that. There was a story of one person who wanted to become very rich. Everybody wants to become very rich, right? So I'll give you the method how to become very rich. So this man, every day morning, he will wake up and do some tapas and say, oh God, let me get the first prize in this lottery. It's a very good method to become rich. He kept on praying for a few days and finally God appeared before him. And what did he do? Give him the first prize? No. God scolded him. You fellow, first go and buy a ticket. Then only even I can do, with a capital I can do anything. So that is the story. It's not just apple falling and sleeping and dreaming. Lot, you can't, you have to do your part of it. You have to go and buy a ticket. Please always remember that. Then of course chance will be there. That's what Louis Pasteur said. Chance favors a prepared man. That's how we can become a genius. Okay, sir, you're talking about genius, but I don't get marks. That's all for the top fellow who gets first rank. Can others become genius? There was a path-breaking discovery by Catherine Cox, researcher in psychology, in the year 1926. Till then, people thought some people are genius, some people make achievement, and the rest just stay there. That was the theory before that. But her research, you can read about her research. I will just tell you the result of that research. It is not the high intelligent people, top intelligent people who become successful. High intelligence along with great degrees of persistence is more rewarding than highest intelligence along with the lower degrees of perseverance. So depending upon your intellectual level, you may have to do little more of perseverance, then you can become a genius. People say that even the biggest brain has used only 10% of the power. You just use 10.1% of your power and you can become brilliant. This is not just what you call advice given to pacify you or anything like that. This is a result of research. And after that, many other studies were there. If you have any doubt about what I'm saying, please go and read what Catherine Cox invented. That's there in Google. You can search and read. So there is no excuse for becoming genius. All of us can become genius. You may ask me, sir, are you a genius? Then my answer is, when I was of your age in BSc or pre-degree or college, nobody came and gave a talk like this, how to become a genius. So you don't have that excuse. I'm telling you how to become a genius. You have to think differently. What is the purpose of your life? Many people have different purposes of your life. The purpose of your life is to find the purpose of your life. Who said that? Buddha. Gautam Buddha said the purpose in life is to find your purpose and give your whole heart and soul to it. Whether it is physics or biology is secondary. Physics is fun. Let's give you some examples of thinking differently in physics. All this, now we are moved out to enjoying physics to how you can become a genius. Think differently is the answer. I give you the situation. I release a ball. Football. I release it. And I'm telling you it went up. You all know what happens when I release something. If I release something, it will fall down. But now you have to believe me. I released a ball and it went all the way up. Can you explain this? I think here I will pause and wait for an explanation. In fact, there are more than one correct answer. It can happen. And there are more than one correct answer. I think we're running short of time, so I will. Again, don't tell some names and somebody got Bernoulli's principle. What does it mean? I want an explanation. Don't just give a name or a equation or anything. Just explain what is happening. Okay, I think one correct answer Muralidharan has written. It is filled with helium and gas. Okay, I didn't tell you what is inside. I just told I released the ball and it went up. So it could be a gas which is lighter than air. It's as simple as that. It will go up. So think beyond. That is why it's called what's called thinking differently. Everybody sees all the sky and all that, but somebody starts thinking differently, and then you find what is the reason for that. Okay, so this is. But there is one more answer. Somebody said I am standing upside down. No, that is not the correct. Okay, at a different level you'll find, but not a physics answer. So there is one more answer for this. Zero gravity. Zero gravity, it will not go up. It will just stay where it is. Simple. I didn't tell you where I am standing. I am standing at the bottom of the Atlantic Ocean. I am standing at the bottom of the Atlantic Ocean and releasing the ball. Where will it go? It will go only up. Next question. Next example. We all know from UKG that a convex lens is used to converge light. Anybody has a doubt? We all know it. Okay. Now my question is, can you use a convex lens as a diverging lens? Yeah, somebody has got the answer. You just have to stand away from the lens. Otherwise, you have to think of complicated questions by filling the lens with some medium and putting the whole thing in another medium and all that. But this is the simplest answer. See, is it converging or diverging? Is it converging or diverging now? So think beyond. Remove your limitation. You're all thinking only up to the. Most of us are thinking only up to the focus. Imagine. Then release the boundary and think further. That's how we become a genius. Now let's talk about the three brilliant people. There's a movie called Three Brilliant Students, right? Or the name was something else. Okay. Now let's talk about these students. There was a principal in a college, and all the games were going on, cricket game was going on, and people are cutting the class. So the principal wanted to prevent it and put a fine. The principal said, whoever misses one day will have to give a fine. Whoever misses another day will have to square that fine and give that amount. Whoever comes on the third day will have to square that amount and give the fine. Like that it goes. Then the principal is very kind. So first day only 10 paise. No. First day if you miss only 10 paise. Then these three idiots miss something like 1 week. You can calculate actually. 10 square is how much? 10 square paise second day, 10 square paise next day, 10 square paise next day, like that. So the first fellow came with a big bag full of notes and delivered that to the principal. And the second fellow came, smiled at the principal and just gave 1 rupee and escaped. Principal said yes, didn't punish. He just gave 1 rupee. How did he manage? You know the amount is going to be 10 square. You can think of it. I thought some people can. He said first day 10 paise. Second day 10 square paise, which is 1 rupee. Third day, what is square of 1 rupee? 1 rupee. Fourth day, square of 1 rupee? 1 rupee. Like that. And then comes the real intelligent fellow, the third one. The third fellow comes and doesn't give anything. Hi, madam, and he goes. That also was acceptable. The principal did not find fault. Why? The clue is the previous answer. 10 paise is, Parvati K has written. 10 paise is 0.1. So second day you have to give 0.01 rupee. Next day 0.01 square rupee. So finally, if you miss 7 days, you don't have to give anything. The last day, what you give the last day is the square value. So think differently, and a no-hope situation can be saved by thinking differently, creatively. Let's go to some old stories. What is happening in research is this actually, if you look at it. Research means take a different point of view, different design approach. Look at old things in a new way. And when the going gets tough, the tough get going. That's how research is going. Change the viewpoint. change your perspective. Give up giving up. This is how research is going on. I hope many of you will take up research in physics. So this is what you have to do to become a successful research scholar. So right now we will think of how to make the tortoise win. Of course, in the story the tortoise wins, but the tortoise wins because of a defect of the rabbit hair. It sleeps. It sleeps when you should not sleep. So winning from the other fellow's foolishness is not the real winning. You have to win by yourself, your own strength. Because the other fellow may not be a fool. Okay? Other fellow may not be a fool. You can't count on your competitor being a fool. So one of the methods, thinking differently, you can solve this problem. Right? That is one method of solving this problem. And let us go to another old story. What is the method? By now you would have guessed. Thinking differently, you can solve the problem. Right? Now, by now you know the trick. So you can answer the third one easily. The crow put some stones according to the story, and but it won't work. I tell you, it won't work, because you try that. If you put stones, will you get drinkable water? That much water from that? You try it out. It depends on the level available. Of course, I think all my audiences suddenly become genius. Many people are searching the correct answer. Good. I think my lecture is successful. Anyway, I am going to complete in a few minutes. I will give you the next take home, although I have not written as the next take home. It's an interesting website, Physics Girl. It is called Physics Girl. A very smart physics girl there gives all the nice explanation about lot of physics around you, physics happening around you. So you can note down that, or you just search for Physics Girl in Google. You will see. Yeah, it's very interesting and inspiring, especially to all girl students. And it's very interesting anyway. So very nice explanation. So far, whatever I have heard, the explanation is technically correct. And if it is not correct, somebody will send you a mail and she will correct it anyway. So this is very nice. You should not miss it. You should note it down. Finally, okay, physics is tough to me. Physics is so stressful. Physics is such a complicated subject. It's like a mountain of Himalayas, Everest. How do I climb that? If you ask me about climbing Everest, I will say, oh, what nonsense. It's all complicated, extreme cold, and you have to take oxygen, and you will be tired, and the Yeti will come and eat you. I won't go for that. It's called an inconvenience for me. But you ask Tenzing and Hillary and many other people who have climbed, they say it is an adventure. So an adventure is an inconvenience rightly considered. An inconvenience is an adventure often which is wrongly considered. So there are two methods to climb the Everest of physics. That's what I'm ending with. There are two methods by which you can. One, oh, you become very tense. Oh, how am I going to do that? It's all there. Mathematically, it is too mathematical. I have to learn this, I have to learn that. And then I have to try and a lot of books to read. How am I going to do that? Get stressed, very tense. You become very tense. That is called the tensing method of climbing Himalayas. The tensing method of Himalaya of physics. Okay, if I'm calling that as a tensing method, what will be the other one called? The hilarious method. Robbie Sion has answered. The other method, the hilarious method of doing physics. And that is precisely what I want to introduce to you. Okay, this is the hilarious method of learning physics. Go beyond the books. Try to think and think differently and try to get, like the questions which I was asking. It's all there in many sources. Go to the sources, find out such interesting. I already given you several, I think 5 or 6 resources. Go through all of them, and any one of them will be actually sufficient. But you can go through whichever your time and your time permits. But what I have given is the bare minimum. All that, whatever I have given so far, you should, those take homes you must visit. I'm sure nobody will find it boring or useless or something. So you will, if you really want to see that this 1 hour you spent with me is meaningful, then you have to actually do that. That will be the part. Okay, now I'm going to ask you a question. Okay, you have been here listening to me for more than an hour. I will ask you a question. What was my first picture? What is the first picture which I showed? Sometimes in an interview, they ask such questions. Yeah, the first picture was an old man running naked, or young man, whatever. A man running naked was the first picture, and I said you should not have such picture. So I done something which is not nice. So how do I make good for it? If I have done something wrong, I must make good for it, right? So I am going to correct my mistake. The first picture was that. The last picture is going to be a beautiful girl. Fine? I think audience will be very much interested. So let me go to the last picture. No, that's the first picture. Sorry, that is the first picture. Many of you look like this. I know boys are also there, but within that understanding, many of you look like this now. Now, I want all of you to close your eyes and imagine what will happen after 20 years. Just look at this picture now. Don't think of anything else. Just look at the picture and just close your eyes and imagine how you will become. This is how you are now. How you will be after 20 years. That's what you have to imagine. And then you will see that, of course, physically, you're all going to grow up. That's definitely there. But when I said beautiful girl, I didn't mean only physically. Also physically also, not only physically, by physics also. Okay, you have guessed who it is. Right? That is Madame Curie. And she's a very inspirational figure. Please note that one point I would like to make here. I'm not really telling that Nobel Prize should be the aim or Nobel Prize is the ultimate in the world. No, not really like that. But it is a measure. I am just saying that it's a measure. So that's a measure of success. Not that that is ultimate and that is the only thing and all. Why Madame Curie as an inspirational figure? Because she got the Nobel Prize in physics. Not only that, she got the Nobel Prize in chemistry again. The details are given on the slide. Not only that, she was the first woman to win the Nobel Prize. The only woman today to win it, two fields, physics and chemistry. The only person to win it in multiple sciences. So it is not just a lady who got Nobel Prize. It's much beyond that. And today's cancer treatment, all that came out of her discovery. But at that time, the researchers did not know about the dangers of radiation. Unfortunately, Marie Curie passed away having cancer, radiation, because of the radiation out of the things which she handled. Now we know how to handle those. But when she discovered it, how did she know how to handle it? But today she continues to save several lives by sacrificing herself. She continued to live several lives. So what is my message when I leave you? You can read what Maxwell asks. When was the last time you did something for the first time? If I end this talk by telling all of you should become like Madame Curie, most of you will think it's a fantastic lecture. Oh, wow, very good message and all that. But I'm a realistic person. I don't want to give a false. If I say all of you become, we are sure that all of you are not going to get Nobel Prize. Some of you may, but all of you are not definitely going to get Nobel Prize. So what is my message? Not to become a Curie, but become curious. That's my message at the end of it. That's what you can do. There is no excuse for that. And in the process, you will become a genius and all that. What is the best subject in the world? I think all of us will think physics. There is a lecture. Somebody gave a lecture in my institute, and that was a fantastic speaker and a fantastic lecture. At the end of the lecture, I was thinking, hey, why did I take physics rather than chemistry? He was telling chemistry is there in our life from the time I wake up onwards, chemistry. So I was so fascinated. I was wondering, why did I take up physics? I should have taken chemistry, such a thing which starts early in your life. He said, when you wake up, what do? You brush your teeth, paste, chemistry, and then you have your coffee, food, chemistry, like that. I was very much impressed. The next day when I woke up, I was thinking, what do I do when I wake up? I open my eyes. I get light into my eyes. Optics. This is more better than chemistry. Because the first thing I do after waking up is opening my eyes. Then I was very happy. The third day when I was waking up, I thought, what do I do when first I wake up? I open my eyes. How do I open my eyes? lot of biological processes, muscles, blood, the information going through the nerves and all that. Oh, biology is really a fantastic subject. So I understood biology is really a fantastic subject. And then the next day when I woke up, what do I do first? I open my eyes. Oh, my eyes, my body. Then who am I? What is when I'm opening my eye? So is this eye different from my body? Because I said my body. Then it becomes philosophy. Okay, let's stop there because that is meta science. We are in metaphysics, not in metaphysics, but in physics only. So coming back, that's my message. So don't worry about which topic. Some of you may become engineers, but engineers also, all engineering is based on physics. Today's physics is tomorrow's. So engineers use physics. Today what is called physics is tomorrow's engineering. Okay, so dream the impossible. This is the picture which every student must have. What Sri Aurobindo told is, man may be a laboratory in which nature is making the Superman. Nature is trying out to make a robot which is called the Superman. Who knows? We are all robots made by some superior beings. Okay, if you do some experiment with some ants on a plate, ants don't know. If I pick up one ant, it doesn't know what has happened. It just says, higher dimension. So we don't know. Some experiment is being done on all of us by someone who don't know who to become a Superman. So Aurobindo says, what we see around us is a laboratory where Supermen are being made. Okay, thank you. Fine.
Thank you very much, sir, for your very valuable and interesting talk. Now I request all the participants, those who have any queries, to put it in the chat box.
Yeah, thanks are fine. I accept all your thanks with humble attitude, but I don't have to write thanks. If 250 people write thanks, it will be complicated. Yeah, I would value your feedback. Please give the feedback, and Professor Smita can send it to me afterwards.
Yes, we are collecting the feedback, sir.
Yeah.
I have already posted the Google form in the chat box. Please fill it within 10 minutes to get your e-certificate. E-certificate will be posted into your registered email ID.
I had taken some about 10-15 minutes more than what I planned. But I thought that anyway, even if people have to go for another class or something, the YouTube is there. You can see the rest of it later. I think the YouTube will be there, right?
Yeah.
Anytime they can see.
Yeah.
That's why I didn't bother about the time.
We are recording it and it will be loaded into our college YouTube channel.
Yeah.
We have an official YouTube channel, MSc Insight. It will be posted into it.
Yeah, very good. I have seen good lectures in many colleges, a few colleges at least, doing like that in Kerala. That is a very good thing because anybody gives any lecture, everybody in the world can use it now. If you put it in. Thank you for all your nice comments.
In YouTube, there is one question: how Newton discovered calculus? Any story or monologue available on it?
Story and monologue are not available, but Newton's case is very interesting. I will tell you a related story, not exactly an answer to your question. Newton, at some stage in his youth, some 20 plus, he was eager to know about his future. So how to know about future? He bought a book he brought from the library, a book on astrology, and started reading it. And then when he started reading it, there were a lot of diagrams of planetary positions and planets and all that. It must have been an ancient Bhaskaracharya type of book, because that's the only book where astrology is mixed with astronomy and you see all those things. So whatever it is, it's mentioned by Carl Sagan. Then he got interested in the geometry. Okay, he said, okay, then he left astrology and he left, because from astrology he came to geometry. And then he got a book on geometry and then try to understand what it is. Then he bought another book on analytic geometry. And then he found, okay, he was getting a lot of ideas. how to get these ideas, how to express his ideas. Then he found analytic geometry is not also sufficient. So he wanted to buy a book on calculus, but that is not available. Calculus was not available at that time. So he invented calculus. In other words, Newton found that to express his ideas in the language of the universe is mathematics. To write it properly, he doesn't have the mathematical tools. So he had to develop the mathematical tools parallel. Suppose you want to make a building and you want bricks, you think of bricks, but then the bricks technology is not available. Then you invent how to make a brick and then make the house, something like that. No specific story.
One more question is there. Moon and sky is a free fall, but why it doesn't fall on Earth?
That I thought I will leave it to you to find out. Some people have written the answer also. The easy answer will be just to make some some word like centripetal force or centripetal force. Okay, let's say you throw a stone. Suppose you throw it with increasing velocity. That's the starting point to think. You throw it, it will come back. You throw it again, it will come back. You throw it with more velocity, then there is some velocity called the escape velocity. Okay, then look at it. Look up that, and then you will see. What is the reason for the expansion of the universe? Nobody has found out the expansion, the reason for the expansion of the universe. Yeah, it is against gravity. Still, our understanding about the Big Bang and how it happened is still not very clear to give not very good enough to give clear answers to such questions. Father of the experimental physics was Galileo. Why? Because actually even the Newton's laws are statements of some observations by Galileo. So what is the experiment he did, He tried to find out, if I throw something, if I put something on the table, nothing happens. It just stays there. If I tilt, inclined plane, then it starts moving. If I tilt more and more, it starts moving. That's how he started thinking about it. So he was the real first experimenter. He had the idea in some other form of the Newton's laws. So Newton later put everything together in a nice framework. So Galileo is the credit goes to Galileo as the first experimenter. Let me check the chat for any other question. Which was first formulated integration or differentiation? Actually, I don't know the answer. I guess it would have been differentiation. Is black hole the shortest path to another galaxy? Nobody knows the answer. You have to do research and you have to tell me. Does wormhole exist? Why matter and antimatter? There is something called, the basic thing is symmetry. Symmetry in charge, symmetry in parity, symmetry in time. Symmetry in charge. Okay, whatever is there, positive charge. Instead, you can have negative charge there. You can take an atom and make it ulta, in the sense wherever positive charge is the negative charge. For example, Dirac found a particle which is exactly like the electron, but it has a positive charge. So that is considered to be the antimatter corresponding to. So that's the symmetry between matter and antimatter. But then, in the observable universe, we have mostly seen only matter and not antimatter. So the symmetry seems to be broken, or we have not found out. Now, similarly, time, if you make t equal to minus t, Newton's equations still work. But nobody has seen, everybody has seen only a bottle falling and breaking into pieces. Nobody has seen all the pieces coming back and becoming a bottle. So there seems to be an arrow of time. So there seems to be an asymmetry with time. If you run a movie backwards, everybody will know that you run the movie backwards. The other one is parity left-right. You cannot put your left shoes on your right foot. So there are a lot of experiments going on. People have observed parity breaking in charge time. And so these experiments are still going on. We can't really talk about that antimatter.
Harsha Rahim is asking, is time travel possible?
I don't know. Nobody knows. Nobody knows the answer. So physics is interesting because there are still many questions which are not answered. I forgot who, but there was some research scholar who came to a guide and told, I want to do research in physics. And this was in 1900 or around that time. I want to do research in physics. Then the guide said, not much point in doing research in physics. Everything that has to be discovered is already discovered in the year 1900. Everything that has to be discovered is already discovered. Max Planck. So he said, don't waste your time. And we can only make it more and more accurate, values of it for some more decimal places. But then you know what happened after 1900? Physics was never the same after 1900. So there are unanswered questions in physics, and that is why it is interesting. Wormhole and a black hole. Wormhole is supposed to be a pathway from one point in space-time to another point, whereas black hole, everything just goes and it doesn't come out, except some radiation, which is called the hair of the black hole. And the other question was about dimension. Let's look at dimension like this. If you have a point, it's 0 dimension. Now, move the point perpendicular to itself. Move a point perpendicular to itself. Then you get a line, 1 dimension. Take a line, move it perpendicular to itself. Then you get a plane, 2 dimensions. Take a plane, move it perpendicular to itself. Then you get a plane, a 3D object. You move a plane, you get a 3D object. Now, take a 3D object, move it perpendicular to itself. How do you do that? Actually, it is very easy. What do you mean by perpendicular in a 3D? You just keep the 3D object in your room, go and come back tomorrow. You have moved in time. That is the 4th dimension. Time is the 4th dimension. But theories are there in 11 dimensions now. The universe is actually so complicated that we haven't still fully understood it. I'm not telling that it will be never understood or anything like that. At least many things which are not understood earlier in 1900 are understood in 2000 and 2000. So more things will be understood in 3000. But right now there are many things which are not understood.
Nidhi is asking, sir, is the way of teaching physics in our schools correct? Do we have to go for physics educational research on how to teach physics?
Yes, you take anything. Some people say that teaching is an art. Teaching is an art. I am gifted with teaching, or I am not gifted with teaching, so that's so I can teach. No, that is wrong attitude. You take art, music. It all goes with training. Any musician becomes a better musician if he undergoes training. So there is always this question, Jayachandran nannayittu paadu, Yesudas sammayittu paadu, Yesudan kore training ittinde, Jayachandran actually training ittinde, classical music. The point is, genius may be there, 1 or 2 who can do that, but in general, any art or science or anything, including teaching, requires training. Training, okay, how do you get the training? It's that you finish your basic degree requirement and then you are appointed. There is no teacher training for college teachers. School teachers who undergo some method. So what do we do about this issue? Teachers can only attend the faculty development programs and conduct such programs, and then you can, or there are a lot of resources. The internet is a fantastic place because there is so much of information. So it is very useful. But the internet is also a useless space because there is so much of information. You don't know which one to look at. So if you're lucky, you will come across some good sites which will give you nice, or if somebody gives you the right advice, there may be websites which can give you teaching methodology. There is a lot of research on teaching methodology. And for the children, as students there, I would like to tell you something futuristic. Many of you may become teachers, but the way you teach is going to be very different from how your teachers are teaching today. Because there are a lot of changes in the paradigm. See, for example, if I give a fantastic lecture, what will my student come and tell you? Sir, your lecture was okay, but the other professor in MIT gave a fantastic lecture on YouTube. So teachers face such situation. So what are people going to do? That's called flipped class. There's a flipped class approach. So the lecture material will be given to you upfront. You will be asked to go through it. And instead of standing on the platform and giving a lecture, the teacher will walk around you and see how you are working out the problem. So people like me, easy. I can retire in a few years, don't need to teach you, learning any new things. But when you are going to become a teacher, you have a tough time because you have to learn new methods of teaching. There will not be any more, not now. After several years, by the time the +2 student becomes a lecturer, there won't be, lecturing will not be the main method. Not that I go to my previous notes and go and give a lecture. That is not going to work. So material will be given to you and you will be asked to work out problems. You will help people in working on problems. Purnami has written about 2 methods of climbing mountain. See, it's easy to remember. Who climbed the mountain first? Tenzing and Hilarious. So the other method is the Tenzing method. But you must remember, I am not making fun of the 2 people. I don't know whether how they were in real life, whether they were Hilarious or Tenz. I'm just making fun of the words. I have great respect for both Tenzing and Hilarious. Somebody wants to discuss Corona. Of course, the other Corona, the nice Corona, not the other Corona. I do not know really on the latest researches on campfire phenomenon. Magnetic field of Earth is itself very complicated. People still have a lot of theories about it. First, they thought there is a magnet buried. Then there are a lot of. See, finally, nowadays the latest understanding it is you don't need actually iron, cobalt, nickel to become to get magnetism. Magnetism can occur out of spins, various reasons. First, people were thinking there are ghosts inside the magnet. That is why it is able to lift. And what do you believe now? You no longer believe in ghosts, so only you think that there are spins. People said there are spins sitting in the magnet, and that is the spins align and all that. And now, spins are also not the latest picture. It's electron orbits. Orbiting electrons is what is there in the magnet. That is the latest picture. So the pictures keep changing. An idea becomes a scientific idea. It becomes physics or science when it is universal. I do the experiment, you do the experiment, you get the same result. Or if you don't get the same result, you know why you missed the result. There are some experimental parameters. So that is a universality. And then you should be able to predict. You should be able to predict. And once you predict something, and that prediction that's what even general theory of relativity was proved by experiment, by observation rather than experiment, which was the observation of some phenomena, not. So this is how it is. And now that initially somebody told you were expecting something about the career and all that, the point to understand is BSc is not sufficient to become a physicist. No, BSc is not the only thing. So when you are doing BSc, suppose you are now in a BSc course, you have to make the best out of it by going to the various resources. If you did not understand what your teacher told about a particular topic, classical mechanics, it's not a problem. You don't worry about it. You can attend lectures by anyone in the world. All people in the world are given interesting lectures, MIT, wherever, IIT, everywhere. Those lectures are there in YouTube. So you read that particular topic which you could not understand. You cannot be reading, going through all the lectures. You listen to a few people, and whomever you think is the best in your opinion, that you can, or you ask somebody, teacher or senior or someone, and then go to that lecture. And okay, today I didn't understand what is Lagrangian. Then you listen to only that part which explains Lagrangian, and you will. So that way you improve your knowledge in physics and try to get into some institute like IIT where you can do MSc. You know that IIT doesn't end with JEE. Many people think that IIT is for BTech. So you write JEE, if you get in, you go to IIT. Otherwise, the IIT doors are closed. No. If you don't get into JEE, you can still go. You can do your engineering and go for postgraduate. You can go for MSc. Many people don't know that there is an MSc course in IIT. MSc in physics, for example, chemistry, all. So you do your BSc properly, write the competitive exam. Yeah, there is a competition, there is an exam. You write that, and then you will become a proud student of the IIT. And Professor Smita is one of them. I had talked to her, and she came here. So many people from Kerala. Why I'm telling that is, many students from Kerala do come. Okay, JEE is not the only door to IIT. You can do your BSc and then try to get into any IIT which offers an MSc in physics. Even if you come through JEE, there is a physics course, 5-year integrated physics course in some of the IITs. Okay, so you do MSc and then you get the benefit of IIT. Why I'm telling benefit of IITs, you get more opportunities. You will have, thus you can ask Professor Smita, she will tell you. Okay, now suppose you don't miss that also. I don't get MSc in IIT. Then what do I do? PhD is available for you. You can do PhD in IIT. Okay, then still you will get a flavor of IIT or any other IISER, for example, such institutes. Okay, even if you don't get PhD, postdoc, you can come as a postdoc. So JEE is not the end of IIT or at such top institutions anywhere or abroad. Now the world is becoming, education is becoming really universal, and there are more abroad universities, foreign universities coming to India and all that. It's not only IIT. I know about IIT, so I'm talking about IIT. That's other institute. Okay, my point is, the specific point I would like to make to all students who are doing pre-degree and BSc and interested in physics is, unfortunately, mathematical toolbox is not given the importance that it deserves. So if you have any interest or any idea of going for higher studies in physics, you must pay attention to mathematics beyond what is done in your physics courses. Working out problems. Nobody asks in a higher institute, write down Newton's law and give 3 examples. That question is not there in any exam paper of institute like IISERs, IITs, IISc. What will be the question? Question will be at a higher level. You will be given a situation and you will be asked to solve it using the principles which you learn. So that is where you have to, it's not just remembering, it's just applying it. I was trying to give you a taste of it through some of these examples. So try to learn that art, going beyond what is there in the text, and mathematical. That's the most important thing, mathematical. See, for example, when the IIT exams were previously, each IIT used to conduct the MSc entrance exam for itself. So in our IIT, most people used to be from Kerala. But now it is a national exam, and number of people from Kerala has reduced. People from Bengal, West Bengal, people from Andhra Pradesh are coming in larger numbers. Why? Simple reason. Andhra Pradesh is strong in mathematics. Their syllabus, the way they teach physics, is using mathematics as a language. West Bengal, they have a respect for science. Not the top, all the top students do not go for engineering. They have a respect for science basically, and mathematics. They do it in the proper way. So mathematics take care of your differential equations, calculus, in general calculus, and particularly differential equations and all that. And mainly calculus. And that is the language of physics. Just like we discussed about Newton and all that. So that is one point which you may be missing or you may not be aware of when you are in Kerala, Tamil Nadu, etc. That you have to take care of your use of first the techniques, tools which are taught in the subsidiary mathematics, and then it will be useful in physics. So BSc physics alone doesn't make you a scientist. You have to necessarily go through MSc and PhD. That is what you have to keep in mind. And of course, there are scientist jobs in places like ISRO, DRDO, and all that. So that's also there. All that are competitive. So an ordinary BSc is not sufficient. You can also do courses from full course by other universities. And see, all syllabus and curricula are for average students. Any class, 10th standard school, anything is for an average student. If you think you are a bit above average, you can make use of it instead of placing around. You can do a course given by another university. Many free courses are there. Some of the courses are there where you can even get a degree, but for that you may have to pay. So that doesn't matter. Getting an official degree, that doesn't matter. You have to learn. That's more important. And try to get into institutes, other institutes where research is going on during your summer internship and all. That is another clue to get exposure to that. There are several students who have come to our laboratories, and then they have become scientists all over the world. So, but of course, if 1,000 people write to me, I can take only 1 or 2. But then there are other institutes, other professors you can write to them. I think that's about the career part of it, I would like to say. Let me see if any more.
Sri Bala is asking, why according to you restrict students from entering a field of research?
I'm not.
How can one select a research area?
Research area, when you select a research area, you have to think of a few things. First, it must trigger your interest. But then there is a problem. All of us are interested in physics mainly because of astronomy or something like that, or something, generally. But if you take the statistics, I have seen so many students. Out of 100, I think 70 people are interested, 70% is interested in doing astronomy. Because it's fascinating to think of the Big Bang and universe and all that. But as a research field, that may not be the most promising one. There are fantastic things happening everywhere in many other fields. For example, nanotechnology, biophysics. Biophysics is another thing which is coming. So you have to see what your interests are, and more interestingly, what your talent is. Suppose I am very good in mathematics. I understand and I do problems. Then I can even go for a theoretical physics, including theoretical astronomy or theoretical high energy physics and all that. But if I am more of a doer, then I should go for an experimental field. But both are required, but relatively. Even then, somebody may be a better doer than a better thinker. That's right. Not thinker, rather mathematics. Mathematics is the language of physics. Don't try to become a theoretical physicist if your mathematics foundations are shaky. Okay, if you can make it better, fine, then you can do. That is one thing. And there are material science oriented researches where chemistry knowledge or interest will be useful. So don't join a research project in material science related, developing a material, medium and all that, if you don't like chemistry. Some people don't like chemistry. I find organic chemistry very tough. When my sons were in 10th standard, I found the organic chemistry book so complicated. 12th, I was thinking that, oh, how do these people get good marks in that? So it's people's attitude. Biology. If you don't like biology, if you're not interested in that, don't go for biophysics. On the other hand, if you're interested, biophysics, the physics of living things, is a very interesting topic. Very little is known about it. And many things, many new discoveries are going to come in the next century on biophysics. So if you have an interest in that, you can try to go in that direction. It's coming up. Previously, people thought that biology students thought that, oh, that mathematics and all we don't want, let's say. And mathematics physics students thought that, oh, we don't want biology. They don't generally like that. But today, mathematics has invaded all fields. Even if you want to do biology, if you want to do genetics and all that, you have to have mathematics. So there is no escape from mathematics, which is the language of science. So the areas, as far as areas are concerned, yes, many interesting things are happening in nanotechnology, material science, astronomy, gravitational waves, everywhere. But astronomy and gravitational waves are not the only physics in things which are interesting. And finally, you join that, you may be, okay, somebody was telling the decay of the fundamental constants, the gravitational constant decays. Actually, it's not a constant. So over several years, so some people who are doing research in that, they just think they just wait for it to decay. 4 years, it doesn't decay. So you write a PhD thesis, though it doesn't decay. It's like that. So actually, if you go into that research, it may not be as interesting as you think from outside. So have a broader mind, and you have to do your MSc. At that stage only you will know. After doing the MSc first year, you take some elective courses if they are available in your college, and then you will get a better perspective of what it is. So do your BSc properly, treating all parts equally, and mathematics also as a part of physics. That's how you have to do your BSc. And then after that, when you go to post-graduation, you must go. If you want to become a physicist, you have to do that. And when you go there, you must think of, slowly you will come to know about various fields, and then you can pick what fascinates you. Not only what fascinates you. When you go to research, it is what you do, whether it is going to be fascinating or not. Okay? In any of these fields, fascinating discoveries. Research is finding something new, and that is fascinating. So without a prejudice, At MSc level, you see what are your orientations, your talents, and where do you think you can do well. And then, of course, frontier area. All research is in frontier area. All PhD students have to publish new results to get their degree. So that's the perspective of that. Somebody talks about interdisciplinary. Yes, interdisciplinary research is also coming up in a big way. And just like, see, physics, chemistry, all the thing came after some centuries only, not in the very beginning. Only knowledge was there. And later, Leonardo da Vinci is a physicist or biologist or artist. But now physics, chemistry, etc. After several years, it will not be any more physics, chemistry. It may be interdisciplinary. So interdisciplinary areas are also, but for that, first you have to become good in your own discipline, basic discipline. Yeah, somebody asked about a YouTube channel. I don't have my own YouTube channel. I am not also given too many lectures on YouTube, but I am planning to make one.
One more question is there. Can you please explain briefly non-linearity based on polarization?
That is my field. Actually, I written a book on it. I written a book on optics. The world is not linear. The world is non-linear in all sense, not only in physics sense. How do you know? Suppose one banana is 5 rupees. I don't know what is the price in Kollam now, but if one banana is, what is the price of 12 bananas? Not 12 into by 60, you will not give that. If you buy 12, you will get a discount. So it is not linear. The world is not linear. What about physics? Before coming to polarization, let's talk about stress strain. So there is stress. If stress increases, strain increases. You know that, right? And if the stress increases too much, then what happens? Strain doesn't increase linearly. The wire breaks. Okay, so that's what happens when there is too much of stress. And what will people do when there is too much of stress? They take a rope and hang on to a hook. That is called Hooke's law. What is Hooke's law? There is a region in which strain is proportional to stress. Beyond that, something odd happens. So this is called the Hooke's law region. Now coming to the question, what happens when the light is traveling in a medium? Light is interacting with matter and light is traveling in a medium. What light causes is polarization, because matter is charged. Matter consists of positive and negative charges. So it causes polarization. And what is polarization? Polarization means pulling plus and minus apart. So that's what happens. So when light is an electromagnetic oscillation. Please remember, light is an electromagnetic oscillation. The value of the electric field keeps changing, the magnetic field also. So that changes at a tremendous frequency. What frequency? 10 power 14, 10 power 16. That's the frequency. It's per second. And that is going on. And what will happen to the charges? Charges also move like that. And the way the charges move, if they are linear, let's say, in the sense there is a proportionality between the polarization generated and the electric field. There is a proportionality. More field, more polarization. Then it is called linear optics. Then light just passes through as if nothing happens through the glass plate. Okay? But actually, all from a pendulum example, which is the real ideal pendulum, simple pendulum? When sine theta equal to theta. Okay? Then your pendulum becomes a simple pendulum. But sine theta can never become equal to theta. So it is not linear. If the acceleration is proportional to theta, the angle of the pendulum, then it is linear. But if it is proportional to sine theta, it is not linear. So similarly, in this case also, we have an oscillation, something like the pendulum, we have an oscillation between the positive and negative charge. Where are the positive and negative coming from? Matter is made up of positive and negative. Why do they oscillate? Because electric field is jumping up and down at 10 power 14 units. Electric field is increasing, decreasing, and changing direction. So the charges keep oscillating. This is called the dipole picture. There are other things also, but dipole picture is a simpler one. Now this oscillation deviates from linearity. So just like the high stress leads to some peculiar behavior, high value of electric field causes polarization to become nonlinear. So P is not proportional to chi E, but something else. That's nonlinear. So basically it happens from what happens in the pendulum. Theta is not sine theta. Large oscillations. Large cause and the effect is not linear. That's it.
So there is a query about internship programs provided by IIT or IISER.
Yeah, I know very clearly about IIT Madras, and other IITs and IISERs also have this, and now there are large number of IITs also. What we advertise toward the summer, we advertise a summer intern program, and people are asked to apply in the main website, IIT website. It will be there, and people apply for that. And from that, there is a selection procedure because we can't accommodate all the applicants. Our IIT typically takes about 30 students for summer. Selected on some criteria like your grade, your statement which you make, and teachers' recommendations, and all that goes into that. And these students will be given a training, internship training. Similarly, other IITs have their own methods. One trick is that the newer IITs also have that, and many people crowd around the older IITs, Delhi, Bombay, Kanpur, and all that. So there may be more vacancy in newer IITs. And newer IITs are in no way inferior or anything to the older IITs. They're also, nowadays getting a faculty post in IIT is very difficult. People like me, some have managed in the olden times, but nowadays it's very difficult, very competitive. So the newer IITs also have very competitive people there. IISERs, same story. But it will be helpful. Another clue will be if some of your teachers, you can go through the teachers and they know somebody or something, that become easier. Otherwise, as a professor, if I get 100 applications, what do I do? Sometimes I won't be able to even reply to it because there are too many requests like that. So what I reply, even if some of you write, I will reply the same thing. Go to the website and see the program and apply accordingly. But if you don't get an individual reply, don't worry. There are too many applications. Somebody asked about TAFR. Yeah, TAFR is very good, perhaps the top research institute in India. Top or not depends not only on the institute, but also on the lab and the situation. So, but in general, TAFR is an excellent institute. And the difference between the guides in TAFR and guides in IIT is that guides in IIT are also teachers. They have to teach also for 50% of the time and do research for the 50%. But in TAFR, 100%, they will be doing only research. Teaching is much less there. So you can expect better attention from the guides there. So if you like more independence and occasional guidance, the other institutes. If you want a lot of guidance, then probably you may have to go to PU. Of course, TAFR is very competitive.
There is a question regarding studying geology and forensic science.
Yeah, these things are rather interdisciplinary, and they're also coming up in a big way. And I will just give one hint of that. The gems are the precious stones, which have very interesting color. And the secret of the color was not even understood till something like 50 years back. It has to do with nanotechnology. It has to do with nano intrusions. So physics of these things are becoming more and more interesting. More and more discoveries are being made. And you may also do with some the jewels which you got from moon and all that, which people get from moon. So many interesting things are happening there. And the other one was geology and what are the other topic?
Forensic science.
Forensic. Yeah.
Forensic science.
See, forensics. See, for example, if you touch something, very surface something, if you touch anywhere, you deposit actually a few molecules of some set something, and which is unique to you. And if you shine a high power laser onto that, it will give a pattern, just like your fingerprint. So very easily people can identify, just like fingerprint identification. But the thief may not be aware of that, even touching somewhere and all that. Fingerprint, he will be careful not to put the fingerprint. But merely touching, that also can leave a few molecules out. So this, for example, many of the crimes are now being investigated with a mobile connection and tracing the mobile. I used to wonder, what would have happened if mobiles were not there? Mobiles are always discovered only some 20, 30 years back. Before that, there was no mobile phone. How did police people work and catch the thief? So, technological advances related to physics have a big relevance, and it is becoming more and more prominent in forensics also. Same thing with archaeology. Dating. Archaeology is related to physics through dating, carbon dating, the isotopes, the abundance of isotopes. Isotopes have a half-lifetime. So knowing how much of isotopes are today, you can work back and say when was that.
There is a query about data science. Recently, I also got a invitation from IIT Madras about data science course. Is it provided by IIT Madras?
Yeah, there is a BSc course on that, which is newly started. It will be there in the website. Newly started course, which is an open course, anybody can enter. BSc course on
an online course, right?
Yeah. On data science, you'll get a degree from IIT.
Okay. Purnima is asking, is IIC or IIT bus for MSc Physics?
I think you should answer that. I mean, it's not, see, we should not have a narrow mind and say wherever institute I am there, it is the best and all that. I would say both are fine. Both are fine. It depends on what you do there, how you manage there. Once you enter it, see, there are, okay, let's say IISc is better than IIT. Let's say IIT Delhi, let's say that, because some ranking or something like that. Then, suppose you go to the top institute and don't work very well, don't do the assignments properly, and your friend goes to the lower institute and does all that properly, then you will be the winner in the end. So it also, okay, you can say for the first approximation, all this, though some IIT, our IIT gets number one for the last few years, but I don't really give much importance to that. IIT Delhi, I have seen other IITs, IIT Delhi, IIT Kanpur, they are all equally good. It's not really that one IIT is superior to other IIT. And other institutes also. So it is more, okay, all this institute you can take on par, and what you do there is more important. Just like I told about the Catherine Cox discovery on Genius. Oh yeah, I didn't answer the question somebody has asked. What happens when you fall to the center of the earth? Center of the earth, what happens when you reach the center of the earth? When you reach there, you have a velocity. So according to Newton's first law, you continue with that velocity. And when you move there, the center of earth is attracting you back. So your velocity decreases. It decreases to such an extent, if you actually put in the numbers, you will see that by the time you come to the other end of the tunnel, you have zero velocity. So you cannot cross to the other side, to the US. You will, by that time you will fall back because the gravity is attracting you. The story is like what we started initially. So you will go back there. And then it continues. And then it becomes oscillation. If there is no friction, it becomes simple harmonic oscillation forever.
So now I think it's almost 1 o'clock now.
Yeah. People will be hungry.
But still people are asking questions, I think.
So you can ask some questions which are not answered and which can be answered. Black hole, wormhole and all that, I don't know much about it, so I heard that.
One is asking about how can I be a project assistant or research assistant?
Project assistant and research assistant, there is a website, it's called ICSR, Industrial Consultancy and Sponsored Research. It is linked to the IIT. There you can put your biodata, and it's like an employment exchange. You may be called when there is a vacancy. But these vacancies, project vacancies, happen at random. It's not at one particular time. When a professor gets a project from the government, he wants to appoint some people there like that. But in general, people prefer a PhD student to work in that. So rather than appointing somebody ad hoc, then we prefer to wait for the June or January advertisement and then take a student from that. Because it will be ideal for everyone if the student also does PhD in the problem. While getting the salary as a project assistant, you can also do your PhD. That is so. At that age, you would like to have some money for you. That's why PhD scholarships are there. Joining ISRO, ISRO and all that, you have to look at their website. You have to look for their advertisements. The blue color of flame in space, somebody has reminded me. The definition, the reason is the thing. If it is blue, is the original color, and if it is not blue, it is due to carbon. A lot of carbon particles are generated if it is here in the atmosphere. Carbon dioxide is in the atmosphere. So carbon particles, as such, the particles may look black. When they scatter a lot of light, then it scatters all wavelengths, and you get yellow color or red color, depending also on the size of the particles. If these things are not there, it will be perfectly blue.
One question is regarding future technology.
Yeah, that I had sort of explained. Any field where activity is going on is interesting. So strengthen your basic physics, and then you can try to get into a good institute, and then what is best there you choose. Again, as I said, if you're not interested in chemistry, don't go to material science. If you're not interested in biology, don't go to biological science. If you're weak in mathematics, don't go to theoretical physics. If you're weak in mathematics, first make yourself strong, and then go to anything.
Shall we wind up, sir? I hope all the participants have filled Google form, which was shared. Your certificates will be issued into your registered email ID. Please take care to fill the details correctly without any mistakes. One more question is there any book recommendation for calculus?
Yeah, actually, I had thought of putting that also as one of the gifts. There is something called Firefighting with Mathematics. I forgot the author's name. You can Google it. Firefighting. Maybe I can Google it. Firefighting with Mathematics. And you will get some wonderful book there. Start with Feynman lectures, and then how he introduces calculus and all that you will see. In fact, which textbook, what I used to do as a student is this. I was a student of IIT for MSc, and what I used to do is this. Suppose I want to read something on quantum mechanics. I go to the library, whichever many books people would have already taken. So whatever is available, some 4 authors' books are there. I go and look at each one, go through a few pages. Whichever talks to me best, I take that. So the particular book doesn't really matter. Or you could ask in Google which is the best book in mathematics. I don't have any particular suggestion for a calculus book, but this Firefighting and Mathematics is a good book. For most
problem solving SHORM series will be a good option.
For doing problems in physics problems.
So shall we wind up, sir? Okay, now I invite our head of the department, Dr. Deba, to share a few words.
Good afternoon all. Actually, we have spent the last 2 hours very fruitfully, I think. But we have to thank Vijay sir. Sir, you have said that you have spent some more time, but the participants themselves written in the chat box that each and every moment was quite worthy. So once again, I thank you, sir, for spending your valuable time with us. And I thank the principal, Marathaneshis College, Kodamagallam, for providing us the facility for conducting this webinar. And special thanks to Dr. Smita Thangathan and Sri Francis Xavier for taking their genuine effort in realizing this webinar. Also, our technical assistants, Sri Teddy and Sri Jacob, special thanks for them for assisting us for the conduction of the webinar. And for the last but not the least, we thank all the participants for making this webinar a great success. Thank you once again.